Hello, everybody. Welcome. How's everyone today? Thank you for coming. Get some water, food. It's a pleasure to have you here. Before we start, let's just show, get familiar with each other. Let's just by showing, by doing your hands. How many of you think you are developers? Ooh, awesome. Ethereum developers? Great. So hopefully we're gonna have some amazing and exciting conversations tonight. So tonight the host will be BlockTEST and the Quorum. So BlockTEST crew, wave your hands. Networking later on, and also we're so pleased to have Matt Wright and Felix Chenier join us from the space.
So
Felix is based in New York. He is one of the senior engineers on the Quorum's open source project. And Matt Wright is, hey, everybody wave to Felix.
yeah, people are waving to you, Felix.
Hey everybody.
Can you see us, Felix?
I only see Kim, but everybody there as well.
Hello.
Hey, see everyone.
Hey.
And Matt.
And
Say hello to Matt.
Yeah.
Matt is based in California. He's the lead community manager for Quorum. So they are super nice, super supportive. Find them on Slack channel later. Join the Quorum Slack channel. And this event would not be possible without the help from our partners in the dear Boston community. Thanks to all of you to come together on this. So if we're all developers, this may look familiar with you. Tell me how you think. Quick job interview. Do you actually know what blockchain is? No. Do you? No. So am I hired? I guess. So indeed, as we believe, there's no such thing as a blockchain. Because there are lots of blockchains and lots of distributed ledgers, lots of projects built on top. And as we can see, just by simply clarifying that we have collected a huge database of the projects, majority of the projects are still built on top of Ethereum, which is probably 80%. But we're seeing the number of protocols coming every day, and we have seen new projects building on the new protocols every day. Don't worry, we can share the slides. Leave your emails so we can share the slides later with you. And definitely, I think this has been a really, the question or challenge for the enterprises when they think of what, protocol we should start looking at, or same for the developers. Which one is a winning bet for the future? It doesn't have to be this complicated, I hope. But we have lots of consensus algorithm as well. You have POW and delayed POW and POS and delegated POS and many, many others come. But in the end, we find these are all the same questions, but we're getting different answers. Is who decides who is allowed to connect with whom? And how should we balance performance with securities or privacies? And what use cases should we prioritize to support? I think that is what we're all wondering all the time, right? These are not easy solutions. And what we try to put forward at BlockTEST is a framework to say what's most important is let's measure about how interoperable these projects or protocols are. And what are the security features that make them they need to have before they go live for any production-ready production. Well, we're trying to make our efforts by saying here's a sandbox or private testing environment that you can connecting with many different protocols as we're building, but you measure all these performance on a consistent manner. As we see, the blockchain space, you have operating system, compilers or development tools that comprises this called environment, and hopefully there's an environment that can be comparable and be standardized, even for the number of nodes and compared to scalability. And the evaluation framework, this is our favorite. Chart how these speed, fail ratio, accuracy, latency, and cost, they need to interact with each other. And this is a trade-off to some extent. Does it have to be? What triggered us to be so fascinated about Quorum? Just want to share with you. That BlockTEST is platform agnostic. So this platform is about, hopefully providing a comprehensive platform of toolboxes for development and diagnostics of any solutions you want to build on top, which gives you standardized feedback. And this you can tell, it doesn't have to be based on one single protocol. But when we found later, just based on some very simple testing contracts, we measure the performance side by side. If we choose Ethereum or Quorum, here's a performance difference, right? And on Ethereum, you have throughput close to 1, and on Quorum, you have throughput immediately goes to 160. These are exactly same contracts, same smart contracts. This doesn't mean that's qualified. Doesn't mean that Quorum or Ethereum, which one is better, which one is worse. But that means for every single case, for every single contest, potentially there is a way we can measure which one is probably works better. So with this as an introduction, hopefully we will know what is blockchain better after we continue to have this deep dive tonight. Hopefully we can continue this conversation about Ethereum and Quorum and many other blockchains to come. So I pass this to Matt and Felix, and also our team, Pratik and Kim.
Welcome you all. Thank you for coming again. I really appreciate that for staying with us. And tonight, the remaining session will be presented by 4 people. Matt from as a senior associate in the Quorum community manager from JP Morgan, and Felix, the Quorum developer advocate and also in charge of the Quorum development in JP Morgan, and me, Kim, I lead the software engineer in BlockTEST, and Pratik, our blockchain engineer. And first, let me switch to Matt, I think.
All right, cool. Hello, everybody. As Kim mentioned, Felix and I work on the Quorum team with JP Morgan. And yeah, we're trying to do a lot of amazing events with the developer community. So thank you so much for coming, first of all. To dive in on what is Quorum, I'm sure you all are familiar to some extent. Quorum is, a fork off of Go Ethereum. It's a JP Morgan project. And, essentially we've added privacy emission features that allow for private transactions with a permission group of known participants, so that it works better in an enterprise environment. And so we've been seeing a lot of interesting use cases that, a lot of businesses want to use public Ethereum, but they don't have the privacy they're really looking for. So, Quorum's a good solution for that. And if you have any more detailed questions on, what is Quorum, more on developer documentation, reach out to us on Slack. This is 24/7, and I don't think he sleeps. But we can always answer some questions. I guess we'll move to the next slide. Kim, I don't know if you can move the slide from here.
Yeah, sure. The next slide is about the use cases.
Yeah. So just to give a little bit of context on the on the project that use Quorum prior to going into how to use it with the public chain. Essentially, we have a use case with Brazil Central Bank to facilitate private transactions. Some of the issues they've had, there are, essentially there's been telling an email to share data on, we have bullet points here, but insurance regulations, securities commission, pension authority, it's still pretty manual. And so they've officially used Quorum to make these transactions more secure, private, and automated, essentially. That's an interesting use case that we're seeing. Another one would be Synaptic Healthcare Alliance. You can Google this, but essentially it's a group between Aetna, Healthcare, Humana, there's like 5 others that are using Quorum to essentially create direct for healthcare providers and put it on the blockchain, on Quorum at least for that matter. And so it's a way to make it more efficient. The last use case that we've been working with, that we've seen, is Vax. Vax really cool. They're essentially changing how energy value chain, and so with shipping of oil, a lot of other commodities, have the gathering, the processing, the transportation, storage, and Vax is a partnership between Shell, BP, ING that are trying to make this paper trail basically eliminated. Make sure there's no loss of data, and essentially make it just a lot more efficient in terms of overhead and energy being used for the time being. So this case being, and there's a ton more. If you guys want more links, join me on Slack. I'll send you guys a whole bunch, but there's new ones every day that we end up finding since Quorum's an open source project. There's use cases all over the place, and we're doing our best to support these teams. So, and then the next slide, I think it starts diving into the technical stuff.
Yeah, so the next slide will be into the technical slide, technical part, and we will take over. Yeah. Okay.
Thank you, everybody.
Yeah. Thank you, Matt.
Hey guys, so we are going to start the technical presentation now, and we are going to see some of the Ethereum tools that can be used with Quorum with some slight adjustment. And the tools that we are going to cover in this session are Truffle, Remix, and MetaMask. So let me start with Truffle. The prerequisites, if you are following along, you would need to do these things to continue with us, or we'll give you a link to the slide and you can try it at home also. That's cool. So the prerequisites that you would require are the 7 nodes example in your local machine, Node.js, Chrome browser, and any text editor which you're comfortable with.
Maybe we'll go to the page of the 7-node example, which is right there.
So I can just, so this is the link for the 7 nodes example, the GitHub link, and they have pretty decent documentation for setting it up with Vagrant. The other way is to set it up with Docker, and once this is done, we would be able to run the nodes with any of the scripts that they have in there. They have a couple of different consensus protocols, and there are different scripts associated with those. So you can use whichever script you want to try Istanbul or Raft consensus.
Yeah. Their setup guide for Docker and the Vagrant are very easy to follow. And the example you will see today, we use the Docker example to set it up. And we're going to show you the Docker images. So let's go back to this.
Okay. So we can start with the setting up Truffle for Quorum. And Truffle, if you don't know, is a command line tool. which is just used to talk to smart contracts, mainly on Ethereum. And it helps you to manage contracts a lot better. You can compile them, you can migrate them to different networks, and it makes it a lot easier to use contracts if you use Truffle. To get started, we have to install it using the npm command. The command is also here. Once that is done, we would make a new directory. So for this part, I'm actually going to follow along with this terminal window here, which has Quorum already installed, so that we can see along if you're not trying it on your laptop right now. So here I'm logged into a server which has these things already present.
I will show them the Docker images. So just give you some flavor. So basically, I don't need that, so that's okay. So when you install the Docker version of Quorum 7 nodes, that's what you're gonna see. Basically, you will have 14 Docker images pulled and installed. Every node will have 2 Docker images, one for the Quorum node, the other for the transaction manager. If you know about Quorum, then you know these are the 2 main parts of the Quorum. And they will interact with each other via different port numbers and mimic simulate the situation where you have 7 nodes and deploy 1 Quorum node on each of them. But now we have 7 Quorum nodes deployed in 1 virtual machine, which makes it easier to demonstrate.
So I'm gonna start with making a new directory called Truffle project. And I'm gonna go into the folder and initialize Truffle by typing Truffle init. So this sets up Truffle in this folder. Next, I want to create a truffle.js file with some settings for the network that I want it to connect to. In this case, it is going to be on 127.0.0.1, which is the local host, and the port is 22,000. So this is node 1 out of the 7 node example, which is running on Docker. So I'm gonna just create a new file called. Yeah.
You configure this one.
I can create a new one. That's fine. So I'm gonna create a new file called truffle.js. And here I'm gonna add this setting. So this is the default setting for development, and it's gonna be on port 22,000, and this is all given here. I'm gonna save this, and now we have a truffle.js as well. Once this is done, the next step is to create the actual contract. So this is a sample contract that I'm gonna use for this demo. It is just storing a single value. If you look at it, this is called simple storage, and it has a constructor which takes in initial value and stores it in a variable. And finally, we have a getter and setter for that, a very basic and simple contract. So this one I'm going to put inside contracts, into the contracts directory. I'm going to go into contracts, and I'm going to create a new file. Let's call it simplestorage.sol as the example. And I'm going to paste it here and save it. Now I'm going back to the root again. We have a simplestorage.sol file inside the contracts directory. Next, I want to compile these contracts so that we get the ABIs, which is the contracts in JSON format. To do that, I'm going to type truffle compile. And this would compile these this file and put it into the builds folder. Next, I also want to create a new JavaScript file called migrations, which is actually used to pass 42 as a parameter to this contract that I showed earlier. So it would set a variable as 42. And to do that, I'm going to have to put it into the migrations folder. I'm going to go in there and I'll create a new name called deploy simple storage, and this is a JavaScript file. Here I'm gonna put the code. So what this does is it creates the simple storage contract and passes 42 over here, and it is set as a private transaction for this. This is a public key for the node 7. In our 7 node example, we have 7 different nodes set up. So this public key, which is shown on the screen now, is the public key for the node 7. With this, it should allow node 7 to get this value 42, and the other nodes should not be able to get that. We'll just show that in a short while. Now I'm going back to the root again, and I'm gonna do the migration with truffle migrate. With this, it is going to deploy the contract, and it is running this file also, which we just saved earlier. Okay, now let's try to go one step ahead. We have done the initial setup, but we also want to be able to see how a transaction is accessible on one node but not on the other when it is on the blockchain. To see that, we are going to edit our truffle.js to add a few more nodes. Previously, we just had development. Now we are going to add these two nodes called node 4 and node 7. So these are the same IPs, which is the local host IP, but the port numbers are different, which allows it to connect to node 4 and node 7 respectively. So I'm going to edit the truffle.js file that I had created earlier. And inside here, I'm going to paste this code, which adds node 4 and node 7. Once this is done, I'm going to save this, and after it is saved, I should be able to go to the console and try different commands. So let me go to truffle console. This opens up the console. It connects to node 1 by default, which is the development node as set in our truffle.js file. So here I'm going to type this, which is to get the value from the deployed contract. In the simple storage contract that we had, we are going to see what is the value we are able to get from there. So here I'm able to see that I get 42. This makes sense because this contract was sent by node 1. So node 1 and node 7 should have this value. But this should not be there if I try it from node 4, which is a node which doesn't have access to this transaction. So I'm going to just try that by typing truffle console network node 4. So this lets me log into node 4, and I'm going to enter the same code, which is to get the value of I from the simple storage. So here I see that I do not get any value. The value I get is 0. Now, moving on, if I try the same thing, instead of node 4, I try to connect to node 7 and see what is the value there. I should be able to see it because node 7 was included in the transaction and it is private for it. So let me just copy this same thing. and node 7, as expected, has the value. This illustrates the main feature of Quorum, which is having private transactions for certain nodes and not the others.
So what consensus mechanisms do you use in that world?
You can choose Istanbul or Raft.
Oh, okay.
You can choose one of either one of them.
Either or?
Yeah.
Yeah.
Gotcha.
Yeah.
Next.
Now, as a last example on Truffle, we are going to see how we can run a sample transaction. To do this, I'm going to copy this code here, which is doing the same thing, but it is setting the value to 65 now instead of the 42 that was already there. And this has to be saved in the root. And I'm going to call the file sampletx.js. So let me get out of the console, and I'm going to create a file called sampletransaction.js. I paste the code here and save it. Now, to send it, I need to enter this. This executes the transaction that we just wrote, which changes it to 65. And now we can rerun the previous stuff that we just had, and the value should have been changed to 65, not 42.
So you see you can ask the transactions. What about smart contracts? They mask as well? Like
Yeah.
can I create a smart contract with only certain nodes?
Right.
API?
So if you deploy a private smart contract for a specific node, you can only invoke those nodes to run the smart contract.
I got a question on that, following on that. The way that you frame your arguments suggests, that's what I perceive, that you're very dependent on node 7. What happens if some attack or someone who's very good on this neutralize or shut down node 7? What happens?
Then you lose the status, so you lose your data.
Everything goes down.
Yeah, because node 7 only node 7 has access to the real data. Yeah, that's the security thing. That's the security. It's always a two-edged sword, right?
Okay.
Now, not everyone have access to your data. Only a few nodes.
It's very dependent on node 7
Yeah.
based on what you said on this example.
Yeah.
You
Yeah.
should play with it.
I got a follow-up. So you said data is available with all the nodes, right? So if you still have the private key of node 7, and if node 7 is down, then you can receive the data, right? Because when you come back,
Yes.
and if you have the private key,
That's a good question. If we lose node 7, I would assume we lose that key as well. But if we lose node 7, but we still have its private key somehow, survived somehow, somewhere, maybe that can be recovered.
Yeah, maybe.
So if nodes, that's what I'm asking. Someone.
Oh, good.
Yeah, so if you have any questions, you can forward to me and I can try to answer. The only thing is I can't really hear the questions.
Okay.
If you need any help, just let me know.
Yeah, sure.
Yeah,
Um,
why don't you
okay.
repeat
Yeah.
some of the questions?
Felix, one gentleman just asked a very interesting question. That what if we lose node 7, and then does that mean that we lose access to the data on node 7? Is there any way we can recover that without node 7?
Okay, so that's a very good question. So the disaster, first of all, let me cover disaster recovery. So for disaster recovery, you only need keys from the node, right? So you would need the node key from the guest or from the Quorum client, and you would need public and private key for the transaction manager. That's our orchestration. If you have that, you will be able to recover a node from the start, from the Genesis block, which would be the initial block. And then once you boot up the newly recovered node, it will talk to all other nodes on the network and ask, what did I miss? And because it's participant to the same blockchain, every other node will respond as everything that is missing to. Plus, the transaction manager subnetwork will also provide the missing private transactions.
Okay.
That's one. And the other thing to note here is, let's say you're trying to execute a transaction on running blockchain in Quorum where you want to involve node 1 and node 7. So what happens is if node 7 is down and you try to execute this transaction, your own client will say, I'm unable to do this because node 7 is down.
Right, I think that answers it very well. Yeah. So yeah, if we have the private key, we can recover that. If not, then it's just unfortunate. Yeah. So as next, we will go to how the section that will show you how we can use Remix to connect to our Quorum nodes. So first of all, let's go to the node. So So before we connect it, of course, naturally it won't connect, and that's because it doesn't allow it has blocked this in its firewall, and sorry, I missed this. Remix, as some of you already know, that is a browser-based compiler and IDE that enable users to build Ethereum and the Quorum contracts with Solidity code. Remix. So this, the UI you're looking at is the Remix IDE. You can type in your Solidity code here, which is your contract. You can have multiple contract files, and you can compile it. It auto compiles it, and you can run that. It's a very powerful tool for you to develop smart contracts. And in order to connect that to Quorum, first we have to open the port on Quorum. So here, let me show you the slide first. So what we need to do, if you are following along the 7-node example, what you need to do is you need to change the setting in your Istanbul startup sh to add this line, RPC cross domain and allows remix. Which I already did. I'll just show you. Examples, 7-node, and if we just Istanbul start, and it's not that visible, is it? So let's go down here. There's one line. Okay, there you go. So what we added here, it goes to the end of the page. And let me just show you here. Sorry, my browser is not wide enough. But what we add here is to open this domain port for Remix. And after doing that, you will be able to connect it, otherwise you won't. So here, now we have opened it, and in Remix, what you need to do is instead of in this run, you choose your environment. Instead of using its default, which is JavaScript virtual machine, you use Web3 player. And here you type in your IP address, which is this, and the port number 22020. This will link to our node 1. And sorry, I think we're gonna skip this part. Hopefully next part can work. I'm so sorry about that. So the next part is how we can use. Okay. Hopefully next part can work. The next part is so if it works, say which it totally did when we were testing that in our lab. Yeah. Yes, and if it does work, you will be able to connect that to your Quorum network. You can connect to any of the nodes of the 7 nodes you set up, and you can hit deploy. You can deploy the contract on that as a public contract, because currently Remix hasn't provided support for Quorum to deploy private contracts on the Quorum chain. So all the deployment you made through Remix to your Quorum chain will be public, and you can try that. And the next thing is we're going to show is how to use MetaMask to connect to Quorum. Hopefully this works. MetaMask. Okay. Chrome extension. So, okay. I already have MetaMask installed. I'll enable that. And here's MetaMask. As many of you already know, that it's a very good tool. It's an extension for you for you to manage your accounts and to show your account balances and make transactions. And apparently that doesn't work either. Somehow the port from here to the same node doesn't work. So it's very likely that the 22,000 port from here to our node doesn't work. It's blocked by a firewall from here somehow. Yeah. So let me see. Yeah. Remote desktop. Do I have remote desktop? If I have remote desktop, then we can do. No, I don't have remote desktop. So yeah, if I have remote desktop, we can do that. But unfortunately, no. Yeah.
We can go the slides.
Yeah. We can start. Sorry, the firewall thing always bugs me.
You can do it on.
It's the same window.
You can also tether to your cell phone.
So, yeah. With the MetaMask, so if it can connect to that via port 22,000, you will see it connects to your account with zero balance, and if I'm not blocked by the firewall here, so and what you will see is you have zero Ethereum, and there's no concept of Ethereum on Quorum. And then when you are in MetaMask, when you're in Remix, instead of using Inject, you instead of using Web3 provider, you're using Inject Web3. It will automatically detect that your MetaMask is connected to a Quorum. And then when you deploy a script, when you deploy a smart contract, the MetaMask will pop out for you to confirm it. And the only different thing you need to do as compared to Ethereum is as Quorum doesn't have support for Ether, so you need to configure it in the settings so to change the Ether cost to gas cost to zero, because it doesn't cost any gas to deploy it or run transactions on that. And after that, it will be if you're not blocked by the firewall, it will work. And that brings us to the end of the presentation. And we are now open for questions.
Should we ask first to answer this?
Oh yeah. Felix. Okay, you're back. Yeah. Okay. Hey, Felix. We have another excellent question from a gentleman here. He asks the main difference between Hyperledger and the Quorum.
That's a great question, and there is no simple answer. But the idea is pretty simple, right? The whole idea of Quorum is to follow as close as possible to Ethereum, while something like Corda or Hyperledger Fabric, or even Borrow, or even some of the other projects like India from Hyperledger, they enforce you to learn all new things about blockchains or how they see the vision of the blockchains. So that's the big difference here. So, and we're doing this because Quorum is an open source project that piggybacks on a whole set of knowledge that's out there already, and that's really the whole difference. But in terms of competition or performance, we're they're different. They're for different things, and they solve different problems. And you pick from the knowledge base that you know, right? So when somebody says, make me a website, so that means different things to different people because of the knowledge that they know. And that's the same thing for when you compare something like Fabric and Quorum.
Yeah, go ahead.
You said they're for different things. So what kind of use cases would be more appropriate for Quorum and what would be more appropriate for Fabric?
So yeah, I can just repeat it.
Yeah.
Felix, so the question is that you mentioned they are for different use cases. Could you give a few examples of some use cases which could preferably be better in Hyperledger and what is better in Quorum?
To be honest, this is a tough question, right? This is the way that all software development is done is you first examine what is the business problem you're trying to do, and then you figure out what tools fit in it, right? So this is what every software developer and every decision maker goes through when they want to build software. So, once you have your set of things that you want to build, then you try to figure out what technology fits the need. And, so you could probably build the same thing on Fabric and on Quorum and on Cord as well, but, the knowledge base for things and how you build things on Ethereum is by far wider and bigger than something like Fabric or Corda, and that's the really key reason to use something like Quorum.
So I heard you guys say there's no concept of ETH on Quorum, but what if you wanted to have some concept of gas and you wanted to charge nodes gas? Could you mirror some sort of ERC20 integration and force nodes to pay gas?
That's a good question. So Quorum gives you very much more flexibility in setup. And so when you configure Quorum, so you could set it up in one way, which is a default, which is gasless. So when it's running with gasless configuration, you don't need gas to send transactions, and you don't need account balances for Ethereum accounts that you executed these transactions with. However, you could configure Quorum to run in a regular Ethereum mode where you set the gas price and you set it up so only the accounts that are funded would transact. And so that's a configuration thing in Quorum. So when you set up a Quorum blockchain, this is up to you to do that.
We have a question.
Yeah. Question perhaps it's not directly related with the Quorum, but do you know any tool that could play the role of MetaMask but on mobile device? Because MetaMask is a great interest tool, but it runs only on the web browser and desktops, right?
That's a great question. So there's several different wallet projects for Ethereum that could be used with Quorum. Off the top of my head, the only one I can think of right now is an application called Uport, and it works exactly like MetaMask but on your mobile device, so iPhones or Android. It's called Uport, one word, and it's spelled UPORT. That's the name of the thing.
Any more questions for us or for Felix or Matt? Oh, there you go.
So when building on Quorum, do I have access to all Ethereum-based tools? For example, if I use Bifrost, Solidity, does it not care?
Absolutely, and that's really the power of Quorum. So you can use Open Zeppelin, you can use Web3, you can use Web3.js, Web3.j. Basically, anything that works on Ethereum works out of the box on Quorum.
Yeah. The only difference will be some of the tools do not yet support private transactions.
Yeah, right.
Yeah.
And that's the only gotcha you want to watch out for.
Exactly. So this is a really good point. So, we show Truffle up front because Truffle supports privacy features of Quorum, and those are really important. MetaMask, for example, and Remix, we actually are working on commits to the public open source repository. So both of those that will add support for private transactions as well, but this is not quite ready yet.
So I get that the power of this is the private transactions. What if you ran your own Quorum network and wanted public and private? Like, could you basically by default run a public, well, quasi-public within your network blockchain, but then utilize the private transaction features?
Yeah, definitely. And actually, that is a feature by design that you can open up your Quorum network to be public. Everyone can access it.
So you don't have to specify which nodes.
When you're making the transaction, that's when you specify who it is intended for.
Or by default, everyone.
Then that's a public transaction.
Yeah, exactly.
Yeah. You can deploy public smart contract on Quorum network, then it'll be exactly same as Ethereum.
Yeah, but I say quasi-public.
Yeah, but and then you can deploy a private contract on some of the nodes. So in the real practice, I think it will be a hybrid between these two, public plus private, and working together become a solution.
Just to add, so Quorum is intended for consortium or private blockchain, and so we're the team that provides the building blocks, and others implement those blockchain networks as a Quorum powered. So the really big one that I'm aware of that's quasi-public, like the configuration that you're actually talking about, is a energy provider or like this whole blockchain system for in Spain called Alastria. And it's something you can Google, and if you Google Quorum Alastria, you will find how to connect to it, and you will see a blockchain being used in the whole country of Spain.
Sort of another follow-on. Really, if you want to deploy this as a public network, your main sort of choice is going to be token economics of whether you're going to have an entirely mutualized computational framework where there is no gas, effectively, or whether or not for the purposes of incentive mechanisms, etc., you're going to create an ERC20 token to use as gas. That's the number one deciding difference between making it public or making it consortium-based or giving it private lawyers much more easily to do a mutualized solution because presumably you have control or at least a way to standardize access to a certain level of computing power for every node that you're delegating to.
Are there ways to, does it automatically take care of like attacks like denial of service? Like if I open it up to the world, like I create a network and I open it to the world, so someone could technically start attacking, doing a denial of service attack on my node. So is that automatically taken care of, or how does that work out?
Taking care of the attacking, defending system.
Denial of service attack.
Oh, okay.
So it's very much like Ethereum, right? So we don't, when you set up a Quorum blockchain, you really need to configure and think about the attack surface. What do you want to expose, and what do you want the world to be able to read from your node? So Quorum and the transaction managers under the hood do protect itself from denial of service and some distributed attacks as well. But when you're opening anything up the world, people will be curious and people will try to hack in, and people will try to do dodgy stuff, right? So you have to be prepared for this. And while Quorum and Tessera and Constellation do some of this work, we certainly would not be, I can't claim that it's designed with full security in mind, just like Ethereum is. Meaning that, if you run Ethereum on your own computer, you don't, your computer is still firewall for everything else. You're just opening it up for the blockchain exchange, blocks and transactions and nothing else.
If your Quorum network consists of one node on your laptop and you decide to, push your laptop to sleep for the night, you effectively committed a denial of service attack on your entire network. So the more nodes that you have, the harder it is to attack everything.
Correct, because it's
distributed.
Because it's the distributed nature of it.
Right.
So,
My question is not about read access, but about write access. So it's a public blockchain. And my question is, to be honest, linked with the throughput. So if I want high throughput, like does the Quorum blockchain automatically react and consider it hypothetically as a denial of service attack and it acts against it, or not? Am I clear?
so is your concern mostly, say you have 3 nodes, and someone decides to join your network with 6 other nodes. They now have the majority and therefore can affect whatever consensus mechanism that they're using. And so if they have write access, they can screw with your network, including passing the throughput past your computational threshold and therefore causing denial of service in the whole network.
I think that can be managed with choosing the consensus algorithm. But my question is more like, if I have a network with 3 nodes and a 4th node joins, whose number of transactions created per second is like much higher. So will Quorum have any reaction to it, like based on the framework itself, or
Is that configuration?
yeah. Can we consider the number of
Great question, and the really simple and short answer is no. So if you allow a new node onto your blockchain as a participant, then and that node becomes naughty, it becomes generates traffic that it shouldn't. There is no built-in control to disconnect or kick this node off the network. However, there is manual control where when you discover that this happens, there is an API on your node and cluster API that says, okay, this node should not be a participant, kick it out. As soon as you run this, the node is now disconnected. The transactions from it are no longer part of your blockchain, and you don't have to worry about this. However, as I said, it's not automatic, and I don't know if it should or should not be. So just to step back a little bit further in terms of Quorum. So Ethereum and the Bitcoin blockchain, they work off a consensus mechanism called proof of work. Basic idea is that you have, let's say, 1,000 nodes. Only one of these nodes will advance the blockchain by creating a new block and packaging X amount of transactions into this block. And this puzzle is being solved for every block that gets created. Quorum actually rips it out and throws it away and replaces this with 2 other consensus mechanisms where you as a network operator have a lot more freedom to allow people onto your blockchain or disallow people from your blockchain. And even if somebody did connect you to your nodes, to your blockchain, you can also just say, okay, this node doesn't belong here, go away. And so we don't cover it in this talk, but we have basically an intro talk that kind of covers this in much more detail, right? So the Quorum, again, to step back, Quorum's pillars or the changes from Ethereum, there's 4 pillars. One of them is privacy, as you saw it today. The second one is pluggable consensus mechanism. So we ship with 3 different consensus mechanisms, and you can pick it when you configure your blockchain, Quorum blockchain. And the third pillar is the one that you were talking about. We call it permissioning, but the basic idea is that it allows network operators or blockchain operators much more fine-grained controls than Bitcoin's blockchain or public Ethereum ever would. And that's the functionality that we're talking about here. This is what allows you to ensure that the node that connects to you, you actually give it permission before it can connect to you. And once it connected to you, you still have more permissions where you can say, no, I don't want this node anymore. So you kick it out from the blockchain. Or there's more fine-grained control here too, where let's say an account is being spammy and you just want to control that account. Again, in Quorum versus Ethereum. In Quorum, you could say this account cannot send transactions, and that's what will happen.
I would say if you want a public network, there's a difference between a read public network and a write public network. I'd say Quorum is best suited for a read public network. And if you really wanted to include less permissioned write access, I would do it through permission nodes, API access to microservices interacting with specifically authenticated nodes rather than allowing anyone to spin up.
But if it's a read public node, then it does make
That's basically how quorum permissioning actually works, right? So basically, when you create the stuff, this is how this would operate, right? So let's say you're already running a blockchain of 7 nodes, and now you want to add node number 8. It's actually not a simple procedure where you just boot up the node and it just works. No, you have to know the network operator of the previous 7 nodes. You have to say, okay, open up configuration for this particular node, and you will provide your node key, and then only then you're allowed onto the network, onto the blockchain.
Sorry, you were saying something?
There was a saying, making the read part public doesn't really make sense, because then confidential private data that you want to keep between yourself and the other person, it's then public, right?
So it's if you have public contracts and public data, as well as private contracts and private data on the same chain, it really depends upon your use case.
Yeah.
So there could be a number of things that you are doing in private that are being, portions of those are being aggregated into public view as a result of inter-entity node transparency. So in the sense of, for example, the price and or so the price of a specific trade in financial securities between 2 nodes may be private, but the volume and the details of what was exchanged, you now know X was sold to Y, you just don't know how much, would be made public. And so the movements of the securities would be public, so that everyone has knowledge of who owns what. So if I want to ask someone to buy something, I know who I can go to and ask, because I know they have it. But the actual price of that transaction is totally still private.
Do we have that level of confidentiality?
That level of confidentiality exists in analog mechanisms already with current securities trading platforms.
No, but in Quorum, can we implement that
Yes.
level of confidentiality?
Yeah, that can be implemented. And just to share with you some lessons we learned from our development experience, it's a very risky thing to open up your private network to the public. Say you build a Quorum network and you open all the ports to the public. It will only take a few weeks, if not days, for an attacker to find it. And the next thing you know, random people will be dumping hundreds of transactions on network and swamping your resources. And then the only solution to that is tear it down and start a new one. That's what we got in the real practice.
When you start a Quorum network, can you do, like, this is a completely separate question. When you start a Quorum network, can you do certain level of configurations that when a node is joining, they are automatically, there's certain limitations that you already set?
First of all, it's a permission network. Only the node that you permit can join it.
Yeah, that's basic.
Yeah.
But for example, like, can I limit the number of transactions that a node can generate in a second, like, already?
Oh,
Can I configure
that level of
Transaction throttling or anything of that sort, is it possible? I think that's what the question is.
Yeah.
Yeah, it's not if you're, I think to step back a little bit, Quorum is designed for private and consortium blockchains, which may or may not be public, but we don't really support fully public mode, right? So again, if you were to think about Ethereum mainnet, how does mainnet get protected from spamming stuff like this? Simple. You pay the gas that you pay in the Ethereum mainnet costs real money. So 1 Ether right now costs around $200. To execute a transaction would cost you anywhere from cents to dollars. So if you execute 1,000 transactions, you have to have an account that's funded to the tune of X amount of Ether. So if you want to create 1 million transactions, you will need much more Ether to do this. Quorum, because it replaces or it removes all of the stuff, it's not protected from flooding. So if you try to spam a Quorum chain, you will be able to do this. So there is no built-in protection for this. Now, what do we actually offer to protect yourself from this? First of all, we tell you, don't run Quorum in public domain. And that's what we want. You really, just gentleman over there says, you really have to think about what it is that you're building and go from there. But if you do run it in a public environment, then Quorum has a mode that works and operates exactly the same way as Ethereum does. You enable price, you enable gas price, and now only the accounts that are funded are able to send transactions. And the way that you control funding in Quorum versus public Ethereum, in public Ethereum, the Ether is mined. So whoever creates the block gets a block reward and sells this reward to whoever needs Ether. In a Quorum network, you would have a faucet, you would have a God account that basically has unlimited amount of Ether, and you would use that account to fund any other accounts you want to allow to transact on this private blockchain. And that's how we recommend running the quasi-public networks.
Right, like that was just an example, like transaction throughput, but are there any kind of configurations that you can do before starting the network?
So I think the idea is that because it is a private network, you cannot enter the network as a trusted node unless you are trusted. So you're trusted, that means you already have that level of thing.
Let me give you an example.
Mm-hmm.
So let's say,
yeah.
Yes, small comment. I think what he's trying to explain, forgive me for putting words in your mouth, is he's trying to question whether or not you can define different tiers of trust and therefore access and or capabilities of the various nodes within the network, correct? So secondary citizens versus primary citizens.
right. Actually, I was trying to put that in an
Once
example.
limited transaction throughput, once had unlimited transaction throughput.
Exactly.
Yeah.
So consider a big bank versus a small bank. Like a big bank who makes, let's say, 10,000 transactions per second. I mean, transactions is just one example.
Yes.
I'm looking at any kind of configuration that you can have on the
Separate different permissions and access.
Right. So when we say permission, like what are the actual permissions apart from being a part of the network?
Or not.
What are the other things that can be different in different nodes? Or are all nodes equal?
So I think the question is like how fine-grained are permissions in Quorum. And so right now, as of today, the permissioning is very simple. Your node is allowed or your node is not allowed. But we are working on the permissioning extensions that actually going to be released in maybe a month or two. That is much more fine-grained, where you go all the way down to an Ethereum account, where whether an Ethereum account can transact or not, can a node be just a participant reader or participant create, participant node that creates transactions. Stuff like this is coming in the next couple of months, actually.
It's sort of the in the name, quorum. If you have a quorum, all people are created equal. As part of the quorum.
I mean, to be fair, Quorum itself is a piece of software, and how you configure it is dependent on your use case, right? So the whole idea here is that we provide software, but we're, others who build on top of it are the ones that actually need to think about things like permissioning, things like privacy, how they apply in your use case, and so on.
Yeah, but there's only one configuration being a part of the network as of now.
Yeah.
Okay.
So, speak of future development, Felix, would you mind to share with us some roadmap for Quorum development in the near future?
Sure. So, Quorum itself is currently at version 2.0, and we are. The main thing that we're doing is we're following the Go Ethereum releases and pulling them into Quorum code base as they come out. So once Ethereum will have, sharding, proof of stake, or whatever else that they're working on, this is actually will be inherited by Quorum directly. So that's one of our main configuration and main things that we that's on our roadmap. The other big thing is enhancing privacy features. So again, when when we give you a demo like this, that's one thing. But when you really start working on Quorum, you will learn issues with this, or you will find deficiencies or caveats and things that you need to keep in mind. So our job is to really simplify this and make it as simple and as seamless as possible. So that's another big track of things that we're working on. And the last big track is really enabling most popular public tools, just like they were shown today, to work natively with Quorum. So those are really three big things that we're trying to do this year.
Thank you, Felix.
Thank you.
Yeah.
Thanks, Felix.
I know we have run over time. Thank you very much for coming, and thank you very much for staying with us throughout the whole session. And we are BlockTEST. We are the ambassador of Quorum in Boston. We work closely with Quorum development team to help our clients to provide consulting and development services to help them design or implement their proof of concept or solution to solve their real problems. So if you have any question about Quorum, if you're interested in Quorum, feel free to reach out to us. And we'll be very happy to offer and help.